Hello, everyone, and welcome to today's panel webinar about the 2024 State of Network Threat Detection and enabling robust security to keep up with business and network transformations. I'm Holger Schulze, the founder of Cybersecurity Insiders, a community that proudly serves over 600,000 cybersecurity professionals, and we're hosting today's webinar. Now, today's webinar is presented by industry experts from ENEA, Arista, and Custody. And Laura will introduce everyone in just a minute. Now, before we begin, let me just cover a few housekeeping items. If you have any questions during the webinar, please use the questions window in your GoToWebinar control panel, and we'll address your questions during the Q&A session at the end of today's presentation. Additional materials are available for download in the handout section, including the 2024 State of Network Threat Detection report we're discussing today. And finally, this webinar is being recorded for your reference, and we will make the recording available to you shortly after the event. All right, now it is my pleasure to introduce Laura Wilbur. And Laura is Senior Industry Analyst at ENEA, and she'll be moderating today's panel discussion. Laura, welcome to the webinar. The floor is yours.
Great. Thank you very much, Holger. I appreciate it. And I am very pleased today to recognize three experts in this field, and I think you're going to learn a lot from each of them. First, we have Rudolph Araujo, who is the VP AI and Security Products, Marketing and Strategy. That's a lot rolled in there at Arista Security. William Ritchie, who's the Chief Technology Officer of Custody, and Danny Shetlal, who's my colleague here at ENEA, who is a VP of our Product Management for Embedded Security. And now for the panelists, I thought I would like to invite you to give a 1-minute introduction of your role, your company, and your technology. So in your whole 60 seconds, we'll start with you, Rudolph, if you'd like to introduce Arista and yourself.
Thanks, Laura and Holger, for having us. So yeah, my name is Rudolph Araujo. I lead up our product strategy and marketing for our security business here at Arista Networks. Just very briefly, Arista has really focused our efforts on zero trust networking, and what I mean by that is really how can we embed key security functions into the underlying network switching fabric, right? As most of you probably know, Arista is a leader in high-speed networking, market share leader in the 100 gig and up space, and the ability to now build security into that same switching stack is very compelling for customers because it allows them to leverage the same underlying infrastructure for security as well without needing overlays and things of that nature.
Very good. Thank you very much and welcome. And again, thanks for participating. And next up, we have William Ritchie, our CTO from Custody. William?
Yeah, thank you very much. Yes, so my name is William, and I'm the Chief Technology Officer at Custody. And I've got 20 years of experience in artificial intelligence. And so my main role was to make sure we implemented a good strategy for artificial intelligence in our product. And basically, we came with three really big vision we had of 3 axes, which was we wanted to make artificial intelligence transparent for the user so they could fully understand what the AI was doing and why it was doing it. Secondly, we didn't want to overload the analyst. So we have an AI that will only alert you when it really thinks it's serious. And the third, of course, was that we had to have one of the best detections possible. It had to be very sensitive to anything abnormal going on the network.
Wonderful. Fabulous. Thank you very much. And you're in the right place here today to talk about network threat detection. And next up, my colleague, Danny. Danny, if you would like to introduce yourself and us and our tech.
Yeah, sure, Laura. So I am Danny Chetla. I'm VP of Product Management for the Embedded Security Business Group in ENEA. So basically, in that business group, we focused on embedded technology, and our flagship product is a deep packet inspection Cosmos technology, which is also referred to as the Cosmos IX engine. So this product has been out there for like 20 years with lots of research and development, and it's tailored to match all the needs of all security and networking vendors out there. So we can say today that we are embedded in 4 of the 5 leading SASE vendors and SSC as well. So our product is focused not only on inspecting packets and classifying traffic, but also identifying anomaly in the network and also extracting plethora of metadata, which can be used as security bricks to build all the different security solutions out there, such as next-generation firewalls, SASE, SSC, CASB, or whatever kind of solution. And obviously, our solution over the last few years has won numerous awards. And the latest one is really related to the newest born of our product portfolio, which is the Cosmos Threat Detection SDK, where we are providing additional value as threat detection insight based on what the DPI inspection is able to provide. This engine is actually developed by customers in collaboration with OISF, which maybe some of you might know, are the people who have designed and made available to the world one of the best IDS solutions out there, which is Suricata. Thank you.
Fantastic. Thank you very much, Danny. And I have a feeling that Threat Detection SDK may come up again. We'll see from there. So now we're ready to dive in. And if we can just take just a moment to make sure we're all aligned on the topic, our definitions here before we head into the discussion. I'll take a moment to say what it is that we mean by network threat detection and why it matters. So the way that we're using it here is for solutions and tools that use insights that are drawn specifically from network traffic flow examination and analysis in order to detect threats that can be of all sorts, not just conventional network intrusions, but it may be insights on users or compromised devices. And many of these, you'll recognize these familiar types of tools that are under this umbrella of network-based, network security monitoring. There's IDS and IPS, particularly of the flavor that's using network data versus host or endpoint data for its functions. NDR, which takes NIDS a little in IDS a little bit further and adds advanced analytics, anomaly detection, which our two guests here today have wonderful NDR products. XDR, which takes NDR and just extends it out a little bit and adds endpoint detection and response and puts it into one package. Next generation firewalls and UTMs. And those are the workhorses of perimeter defenses that have long stood guard on our networks and have multiple functions within them. And then the supporting technologies, which again, that Danny just did a fine introduction on, are deep packet inspection, as well as all kinds of network traffic intelligence, whether it's heuristics or packet sniffers or machine learning, AI, et cetera, to help vendors and end customers understand network traffic. So that is what we mean here. And why does it matter? Well, it matters because network-based threat detection is very important for catching threats that perimeter and endpoint systems can either miss or they're just not equipped to catch, and can add very valuable threat context even to the alerts that are coming from the system. So sometimes when you have endpoint defenses and host infrastructure equipment all saying everything's good, everything's fine, you can look at the actual flows of telemetry data and you can find indications, anomalies that no, everything is not good. So it is very important to have all of these systems working together. And again, the network plays a special role because it really is the ground truth, what's flowing on your network. So there is the basic terrain, the very basic landscape that we're operating within today. And let's dive into the survey findings. And first, we'll look at one of the main challenges that came up over and over again in the responses, and that is around visibility. And when we asked respondents, what is the biggest operational challenges that your teams have, right up at the top was either no or very poor visibility into the global attack surfaces. This was just right underneath alerts, which we'll come back to problems with that. So on the visibility, we wanted to understand how are people compensating for this challenge around visibility and the loss of visibility. And we asked what types of sources and tools are people using in order to gather these network traffic insights. And it's interesting because it's diversified over time. The workhorses are still there, network intrusion detection and deep packet inspection, but also we're seeing a lot of traffic insights being brought through software agents on endpoints. You can kind of see that zero trust influence there, external intelligence feeds, and then device host kernel applications, eBPF, which has become very popular for retaining or gaining visibility in the cloud. So now, with respect to this huge challenge around visibility, I'd like to pause and ask the guest, our panelist here, a couple of questions, and there's two questions. The first one is, where do you today, for your customers, where and how do you extract network traffic insights? And the second one is for this network attack surface discovery, visibility. Do you think today that people expect network threat detection tools to provide visibility, and by that I mean literally like mapping and visualization into the threat detection surface, the attack surface? So first one is, how are you gathering the data? And the second one is discovery. Is that an important role? So for that, I think we'll start with Rudolph. If you would like to take a swing at one of those or both.
Yeah, thanks, Laura. So I think in terms of the first question, there's kind of the usual sources, tabs, spans, things of that nature, right? I think the thing for us that has been most interesting and has driven, I think, the most adoption is our built-in NDR sensor that is on the switches now. And two reasons I think customers have really, latched onto that. One is just from an operational perspective, it's one less thing to deploy, right? Because the switches are already deployed, the access points are connected to the switches. And so it's there, and turning on a software capability to build this NDR sensor is pretty easy and seamless. But the other thing that, I think is probably more important is it gets them into places of the network that they don't have visibility in today, right? I mean, you have that stat of 52% being unmanaged. Our own data, I think, shows that somewhere between that 50 to 60%. So I think it kind of aligns with what you had. And a lot of those we're seeing in kind of campus locations, right? Where it's a small branch office with like 12 people. You can't really put a rack-mounted appliance there necessarily, but the switch is already there. So those are, I think, two aspects that touch on, I think, both of your questions, right? Like, how do you get the data, and then how do you improve the visibility? How do you get better visibility? But I will say briefly to your second question, absolutely, I think customers are expecting the network solutions to actually give them an effective map of their network, right? Because they realize that the endpoint solutions are just blind to, again, 30, 40, 50% of what's on the network.
Wonderful. Well, thank you very much. And that really that makes a lot of sense too, integrating that into the switches, especially with where and how the role your switches play and where they're deployed. That's going to address a very important visibility gap. And now if I could ask the same thing of you, William, in terms of where you're collecting data and this issue of network discovery, attack surface discovery.
Yeah, sure. So we deploy a probe, or multiple probes, a physical probe, and it can be, via port mirroring or via tap. And actually, that's a process that we're very engaged in. So we have one of our chief, networking experts that comes in, because actually that process of deciding where we're going to place these probes is really good to understanding the network and what level of understanding the client has of their own network. And so this process for us, we take time in doing it, but we find it's an essential step of doing. So our physical probes are running Cosmos, and so that's the first point of entry. And then that physical probe will do a first analysis on premises, and then it will send metadata where the AIs will be analyzing that in the cloud. And so the metadata, of course, has to be anonymized, it has to be secure. But yeah, so we find that first step essential in mapping out and helping the client map out what they want to cover and what kind of traffic they want to monitor. On your second point of network discovery, yes, I mean, that's one of our great selling points during the first week. So if our client isn't going to be attacked, how can they know that we have added value? And that's really important for us, because the amount of surprises we get where we say, well, you've said you have 2,000 IPs, you have 5,000, you've got a virtual network that you're unaware of. You have something that keeps pinging the network. Are you aware of this server? And we also, not only do we help map out the different assets, but we also characterize them. And we say, well, we find that this is acting like a web server, this is acting like a Kerberos server, whatever. And we validate that with the client. And the amount of surprises we get during that mapping is great just for selling the product, because they know that it's actually working and we have a good visibility of the network.
Wow, that's got to be reassuring to have some of that visibility restored. And that's a very interesting complement too between the two, with deploying things very strategically with the probes in some of these campus or decentralized locations, with the crossroads and the switches that that Arista is covering, so helping to fill in all those gaps. And Danny, our technology is embedded in a lot of different networking and security products, but have you seen on the security side like some changes in where IXE is being deployed for that visibility function?
Yeah, well, I agree with all my fellow panelists have added, and from what I'm seeing today is that we're seeing more and more security being pushed closest to the user and also closest to the edge, whether it be the branch enterprise edge or the cloud edge. So we are trying to, at least from what I'm seeing our customers are doing, they are trying to get the security really closest to where they can enforce the security policies and all that. So for example, we are seeing firewalls in SD-WAN devices. We are seeing more and more SASE type of deployments where it's running on a POP on the cloud edge with a distributed security functions and all that. And also, as I'm seeing in the slide here, so there are more and more actually agents and all that running on the endpoints themselves, like eBPF or others. So I think in terms of locations, today security is collecting at least data for security is a multi-location topic. You have to take this from everywhere and aggregate the data and have a more holistic vision of what's happening.
Yes, you do. And it sounds like between this group, you've got the bases covered. That's wonderful coverage there. And you're also hinting with collecting all of these data from all these sources. That's gonna pop up again when we get to alerting and challenges with alerting. But let's stay on visibility just for a moment too, because there's another challenge behind this, which is encryption. So to dig into this visibility problem a little bit, we asked, where exactly do you have the most specific visibility gaps, or the most pressing visibility gap? And topping the list was encrypted traffic. And we went a little further then to understand, like here, exactly what are the specific challenges that are associated right now with encryption, which you've identified as your primary blind spot. And when they responded, sadly and both interestingly, the number one impact of encryption was making the network less safe rather than more safe. So I think this is pretty important. We should probably stop a moment and I'll ask you a couple of questions. So my questions for you guys is how, or if, this challenge around encryption can be addressed today. And Danny, I happen to know you work a lot on encryption. So let me start with you. Can you address this for us?
Yeah, sure, Laura. So, well, you know the story. Encryption is not about security. Most people actually confound security with encryption, but encryption is just about privacy. So everybody wants to be private, especially hackers and malwares, because you don't want to be identified sneaking information out of a network or whatever. So, well, I would say to work around encryption, there are basically three ways we've seen today. So the first one, if we're talking about TLS, which is the majority of encrypted traffic over the internet, web traffic, right? Here we are talking about inspecting what is still clear in the TLS traffic about the hello exchanges and gathering information about SNI and all that. So with that, you are able to actually classify the traffic. And this gives you a fair amount of visibility. To tell you honestly, even with TLS 1.3 today, with a standardized version a couple of years back, it still works pretty well. And so that's not a major issue for traffic visibility, at least engines like ours in Cosmos technology. And then the second approach to encryption is actually decryption. So most people don't think about that, but yeah, most of these encryption technologies, especially the TLS ones and even TLS 1.3, which many people wrongly believe it can be decrypted. Actually, it can. It's just the decryption framework is different. So once you decrypt that traffic, you feed that in a DPI engine like ours. And what's important here is just to have clear text signatures for these decrypted apps, which we actually do. And so once again, we can classify, but in addition, we can extract all the metadata which is required to have the full security visibility which is needed for different use cases. And the last one, on which we have done lots of research and we had very good results, is related to AI-based traffic classification. So there are some technologies, for example, TLS 1.3 ECH, which is still in draft mode, but it could be standardized in not long. So the Hello exchanges I mentioned earlier are now totally encrypted, which means this can be identified. So now we will rely on the packets, heuristics, and behavior on the network to be able to map and profile the traffic and create machine learning-based models. And actually, we tested that live on telco networks for the 40 most important applications out there. And we had great results. We are actually, it exceeded our expectations. And so that's what we are working on in our labs today. We are building models for the most well-known applications. So we are around 45 today, and we want to reach like 200 in a couple of months. And that would be the answer to totally encrypted and blinding traffic, where we believe we are ready to handle this kind of traffic as well.
Well, that's fabulous. That's three very important strategies, including, I know that a lot of promising work on the third one for helping maintain the essential visibility that's needed for cybersecurity. And we're providing that at a foundational level, of course, for security solutions that are built on that. But I'm wondering, just William and Rudolph, if you had anything you wanted to add to this challenge around encryption, then I guess I'll make sure I round robin. Maybe William first. Did you want to add anything on this particular topic?
Yeah, sure. I mean, Danny, I think you did a really good overview of the solutions there. And of course you can, and we do use, of course, handshake information, cipher suites, and everything else. But we've put a lot on the AI side, on pretty much your third solution. So what we do is you just use information on the packet size and the arrival time. And that doesn't sound like a lot of information, but actually, if you really work on your AI and you really refine it, you can detect a lot of things. You can detect data exfiltration, you can detect command and control. But these are very, so first of all, the AIs behind them can be quite expensive. They're neural networks, and so they can be quite costly to run. So there's that. And it's a type of detection which has to be supervised, meaning that you have to say, this is exactly what we're looking for. It's very hard to just say, detect anything that's abnormal in this traffic. You have to actually pre-train those models. So we do that. And the other thing is that you still have to consider any anomaly that you detect or any bad behavior you detect by using this AI just on packet sizes and arrival times. You have to take those with a grain of salt, and you have to make sure that you can either put them in an attack chain or you can reinforce it with other analytics before you start alerting people about them, because they are very fine and they will pop a lot of false positives. But that's our approach, and it really does work. So we use it mainly to detect, as I said, data exfiltration and command and control. And I'd be very, I can't wait to try your solution, Danny.
I think there'll be some fruitful collaboration going on there. Well, that's fantastic, and that's very, very promising. And I'm sure for the privacy advocates, that's what you want too, is to be able as much as possible to find threats, but leave things encrypted when possible. And absolutely, that's great. And Rudolph, did you want to add anything there on the encryption side?
You know, I think William and Danny were pretty comprehensive. I just thought I'd give maybe a couple of examples of what we've seen. I think the point that's buried towards the bottom here, the negative performance impact of decryption, comes up a lot in our conversations. I'm seeing at least fewer and fewer customers that want to actually decrypt anymore because the privacy reasons that we talked about, but the costs, right? I mean, if you turn on your next generation firewall decryption, suddenly you need like 3x the number of appliances and so on, right? So I think that's one thing that that sometimes gets forgotten is the cost side of this. The other thing I wanted to say, and I think William put this really well, right? Encrypted traffic analysis is great at giving you signals, but it's not necessarily the only thing that you should consider, right? Like he said, you want to put it in context of everything else happening. And so I'll give you one just very simple example where sometimes we can identify the application that's communicating, right? And so what I tell customers is, look, if there is a browser going out to Twitter, you maybe don't care as much, but if it's PowerShell connecting to Twitter, you probably care a lot more, right? I mean, we have enough trouble with people tweeting. We don't need, bots and IoT devices and PowerShell tweeting. So I think, that's a good example of where encrypted traffic analysis can actually, and over and above the decrypted data analysis, can actually help you with application identification and things of that nature.
Absolutely. Well, I'm very encouraged after listening to the three of you that this is a challenge that we're going to handle. And yes, on the performance end, challenge with description, challenge with AI, and I hope that there's lots of innovative solutions coming there too to help us with both of those things. Now, let's go on to another key finding area where we were getting a lot of concerns around, surprise, surprise, alerts. Not surprise. This comes up continuously, the top of the list, the frustration around alerts. So when we ask, going back to this chart that we saw at the beginning, what's your biggest operational challenge? By far and away, number one here is prioritizing alerts. Similar vein, when we ask specifically about network intrusion detection systems, once again, top of the list, phrased a little differently, is alerts with poor actionability that weren't accurate and they were very noisy. This topped the list of their challenges here around NID systems. And then when we talked, we moved a little bit into what kind of product enhancements people would like to see. Once again, we see alert issues popping up. And here, the number one thing people would like to see is some help, some assist solution that would automatically score and prioritize alerts. And so now for our panelists, I really wanted to ask you, this does come up in every survey. It's at the top with so many brains and so much effort going into addressing this problem. It's not only persisting, but it seems to be getting worse. And my question to you is now, what can be done about this for real? Is this something that is going to be that's going to be tackled and subdued and finally resolved? So we'll go flip back. We'll start with you, William, and then we'll go to Rudolph and Danny. See if you have some thoughts on this as well. The evil alerts.
Yeah, sure. And this is actually something that comes up a lot when you listen to people talk about how AI has changed people from an attack perspective. So in general, what people are seeing is that tools such as GPT that allow people to generate attacks, it hasn't really changed in the sense that we don't see much more complex attacks or new attacks, but we see a high volume of attacks, a volume of threats coming out. But there's a point where quantity is a quality of its own. It means that there is a point where there are so many alerts that you're going to get alert fatigue and you're going to stop using the solution. So this comes from, an increasing volume of real threats that are coming. It also is because a lot of advanced solutions are starting to try to use AI, and you're getting alerts from these advanced tools, and it's in the end sometimes not helping. And you've got a lot of tools that have overlapping functions, and we're not, we're not really prioritizing the unique functions of a new tool. We're actually letting a lot of tools overlap, and they shouldn't. So what we've done is we put a lot of emphasis into this problem, and what we have is actually, instead of having just one AI, we have multiple AIs, and they each work at different timescales, right? And above these, each one of these AIs can detect things, and they can pop alerts. And above this, we've got a meta learner. So we've got this big AI above it that says, well, before you start to bother the analyst, let me have a look at this, and I'll sort of be able to measure and weigh all the different alerts I can see on the system. So, for example, it can say, well, if, for example, somebody's saying, oh, well, I see there's a data exfiltration, we actually have an AI that says, well, I have an AI that specializes in looking at that, and it's not saying anything, so I don't believe that answer. So we actually use AI to counter that problem, and we have AI to prioritize and to really make sure that those alerts are what they say they are. And of course, a lot of threat intelligence, and we use, cyber intelligence to prioritize and put these things into context. But AI was our solution.
Excellent. You're kind of foreshadowing a discussion that we're going to come back around to that topic. Very good. Thank you. And Rudolf, your thoughts on this alert catastrophe?
Yeah, I mean, I think two things, right? Like, one is I'm actually curious how much of this is really influenced by folks that are still on kind of more traditional signature-based IDS, type solutions, where that's kind of biasing their perspective. But I think to build on something that William said, the other thing that we're doing is we're also, like, how many of this large number of alerts is actually tied to the same attack, right? Like, so we're using AI to kind of start to collate things together and say, hey, this particular attack has actually had 5 different stages, right? If you're familiar with the MITRE attack framework or things like that. So being able to correlate those and kind of connect all of those together, I think also helps kind of funnel it back, saying, yes, you see 57 instances of this, but it's actually just one attack with these 3 hosts involved. So I think, the onus is on us as vendors and as providers within the cybersecurity industry to kind of do some of these correlations, right? And I think AI provides a lot of benefit in this particular area, not just in the raw detection, but then in the analysis, if you will.
Yep, that makes absolute sense to me. And what you're both doing is there's this correlation, whether it's correlation across time or across devices, to try and reduce all of this noise and make things more meaningful. And Danny, even though we're kind of a layer underneath here in terms of helping to address alert, I mean, at a fundamental level, does the technology, the deep packet inspection, that ANIA makes, does that contribute to?
Yeah, definitely. I think here what's important is that we provide the right metadata and all that to build the right models, which is important to have much more meaningful alerts and all that. And I also agree with all what my fellow panelists just said. There are multiple sources of alerts and also redundant tools and all that. And also the same problem, having multiple alerts related to it, creates all this alert fatigue problem, which AI is the best solution we have today, I think, to solve. So yeah.
Very interesting. And I was wondering while you were speaking, just for all our panels, if you had your crystal ball, do you think we're heading towards a future, maybe not too far of the future, where alerts will just kind of cease to exist? That will move from alerts to action, from take the reins to our AI and our other advanced systems and just do it. Maybe have the trail to show me how we got there. Let me take a look and understand what's happening. But more and more automation. Do you think we're moving from alert to action? Anybody else have that kind of feeling?
Yeah, we do. And I mean, we definitely. At the start of our company, we didn't get much on automatic response. So lots of people saying, I want to be alerted, but I really want to be in control when I respond to that. And the more it goes, and the less people saying that. We're getting more people say, I just want you to deal with it. I just want you to shut that down. As long as it's not a critical server, I just want you to shut that down. So yeah, we're definitely moving towards automatic response from AI.
Yeah, I'm kind of getting little signals to that. Go ahead.
Sorry, I was just going to say, I think you're seeing all of the buzz around AI agents more broadly, right? Not just in cybersecurity. I think that's certainly to come. I still think, there is going to be a place for a human in the loop. At least for the foreseeable future. Right now, I've been known to be wrong before, so maybe I'm being pessimistic here, or not as optimistic, I suppose. But I think there's definitely a trend towards getting more and more data so that it's analyzed, not just raw data being spread out at the human, right? And I think that's definitely a trend that's going to continue.
Right. And I think if we can solve that, that's a huge challenge to solve. So it's going to be interesting to watch it to evolve. We all want human to stay in the loop, but these advances of being able to turn something into say, there, do this, or we've done that, is certainly, that seems to be gaining more and more appeal with just the volume that has to be confronted. But this is sort of getting into our next topic. I think we've just identified one possible driver behind this particular result, which is when we asked about product enhancements. One thing we asked is, how important do you think it is for network threat detection to incorporate AI for advanced threat detection? And the overwhelming majority, 71%, said they thought it was extremely important to incorporate AI. It wasn't just nice to have. No, this is a must. So we've got certainly amongst you fellows some experts here in AI. So I'm wondering, what do you think is driving? What are you seeing that's driving this sort of belief, this confidence that AI can make a significant difference? And then if there's anything that your solution does that is incorporating AI beyond the alerts and things that we just talked about, how else are you using this to try and improve the day-to-day life of the security professional?
Yeah.
Let's see. William.
Yeah, sorry, I jumped the gun there.
That's okay.
So there are two big reasons, I think, is that one of them is that certain tasks just cannot be done by a human. There are some with advanced persistent threats. If an asset starts by scanning on day one, 10 days after you see some suspicious traffic, then 10 days later again, you see another scan, an internal scan, and then 1 month later, you start to see a very weak signal. No human can actually correlate those across that time, across 1 month. It's just not possible. Where an AI can. An AI can actually say, well, I use either projection onto a MITRE attack, which is a great strategy, or I use advanced AI to actually put all those things together. So a human can't do that, whereas an AI can have a memory of all those. The second one is behavioral analysis. I mean, everything may seem legitimate, and there are no signatures are coming out as illegitimate. There's no known threats, but an illegitimate usage or a strange usage of something, somebody in accounting, a Sunday night is exfiltrating 10 gigs over FTP, and you're like, well, who does that? And it can be more subtle than that. And behavioral analysis is impossible to do for a human. You just cannot, know the baseline of all your assets. It's impossible. So the first one is that some of these tasks that AI does are cognitively just not feasible by a human. And the second one, I think, is that AIs can adapt. If you've got a good AI, it will continuously train on your data. It will understand what's normal and what is not, and you'll have less and less false alerts in your network. And also, it will adapt to the new landscape of threats and attacks, which is impossible with signature-based solutions. So there really wasn't any alternative. We really did need to turn to AI.
Oh, fantastic. Yep, and that's a very good point. Sometimes it takes fire to fight fire. And Rudolph, did you want to add to that?
Yeah. I mean, I think we talked about a couple of the use cases as well, right? Like being able to correlate stuff together, et cetera. And I think decreasing the workload ultimately on the humans. I wanted to kind of give you a couple of other, maybe almost like back-end kind of capabilities that we've been able to leverage AI, right? One is in really ingesting threat intelligence, right, and being able to ingest open source intelligence, because there's so much information on the internet, and being able to kind of crystallize that. And I think LLMs are a great way to do that, right? And large language models. And so that's kind of a use case that we're seeing, not just ourselves, but we're actually seeing customers start to engage in this as well, right? Especially the most sophisticated customers that have their own, data scientists within the SOC or within the security team, right? How can they use AI to kind of get smarter on all of the different threat actor activities going on around the internet, if you will? So yeah, that I thought is an interesting, kind of use case. That sometimes gets buried in all of the stuff that the products themselves kind of natively do, right? The other interesting example for us is with our managed NDR. We're actually starting to use AI now to take the threats that we get from our platform, and then craft the emails actually going back to the customers in a way that's going to be most resonant with them, in a way that's going to kind of bring in kind of some of the asset, significance, put it in context for the person that's receiving it on the other end, right? So another kind of example of leveraging AI, in the context of this larger kind of threat detection, threat response workflow, if you will.
Yep.
Yeah. Sorry, can I just add something? Yeah, I think that's a great point. And this was one of the reasons as well why we started to put a lot of explainability into our solutions. So our AI detects, and it also really tells you why it detected, what its baseline was, what model it was using. And it has educational purposes as well, because people investigate that and they say, oh, this is what beaconing looks like, this is what DDoS looks like. And you're right, actually using AI to explain and to train people is a knock-on effect that we hadn't thought of, but it's really efficient. Yeah.
Yeah, fantastic. Well, I'm starting to see where this high confidence is coming from, giving the good results that you guys are having with some of the solutions that you're bringing right now to help people on the same, then even on the AI side with what we're doing with encrypted traffic. And Danny, I can think personally of like particularly the DPI plus the threat detection helping in terms of the supporting AI from a data perspective and performance perspective, a performance challenge for AI. Does that make sense to you?
Yeah, definitely. I think as part of an AI strategy to handle all of that, so the IX engine and with the threat detection, which plugs on top, brings all the relevant data, which makes this quite streamlined and efficient.
Yep, absolutely. And I was thinking in particular something that you had mentioned earlier too, Williams, with a huge performance gain as well for those using the threat detection core with the DPI. In your case, 3 times compute advantage with integrating that software. And I think that's a whole nother challenge out there on the front with AI, is how to do it in a way that's sustainable, that we can support with resource and resource competition and the need to be careful with our energy consumption. So that's a little something for the future. And now on this, I want to make sure that we have some time to get to the Q&A. So I'm just going to point out a couple of results that are interesting, and we can come back to them maybe at the end. But I think we need to keep rolling to get to our Q&A. But did want to point out these kind of interesting 2 results. One is on deployment plans, and a majority, 66% of respondents said that they plan to definitely implement anomaly detection capabilities within the next 6 to 24 months. 15% weren't sure, and only 2% had no plans. But kind of the interesting thing about this is that means that only 17% actually already have this in place. So that makes one think, I found that a little bit surprising. That means our panelists here, there's a lot of work to be done out there, because that means there's a lot of people that are probably heavily reliant on just simple signature-based systems, or heavily relying on endpoints, so that the solutions that you provide are very much needed. And I think you're going to be very busy over the next short interim period. And then another question, which will be very interesting to see how it evolves, was just about what type of deployment was most effective for organizations, today in terms of network threat detection. Was it as part of a big multifunction platform like a SASE or an SSE, or was it more independent? About 2/3 went with more of an independent, either a sensor with DPI or an NDR platform, or NDR within an XDR platform. But I think this is probably showing at this point that that there's still so much innovation going on around these specific areas that there's a lot of advantage towards grouping these very specialized tools, using a lot of innovative approaches, integrating a lot of innovative approaches alongside the larger platforms, which are also incorporating this network threat detection and response capability as well. So we'll see how over time how that plays out. And now, Holger, before we run out of time here, I wanted to see if you have some questions that have come in for our panelists.
Yes, I think there's a couple of questions coming in. Let's see. Yeah, let's address this one. One of the survey questions was about KPIs, right, for NDR products. And the question is, what kind of metrics do the panelists think matter most for judging product effectiveness? And maybe Rudolph, Williams, you want to take a stab at that?
Sure. Yeah, I mean, I think I've heard this question kind of quite a bit in the field as well, right? Where we're out there trying to sell or pitch to the customer, and they say like, look, I've got 75 other tools. Do I really need another one, right? Like, where does this fit in? And the thing that I've seen most effective from our customers is they really look at this from a MITRE coverage perspective, right? So if you lay out all of the tactics and techniques and look at where do you have gaps in your coverage. And what are the best tools to fit for that? So the most mature customers, I think about it in that way. Like in the survey, I thought it was interesting where customers, the respondents talked about, hey, can you reduce the number of breaches, etc. But it's one of those things. It's like insurance. Like, how do you really know you're reducing the number of breaches because maybe you're not getting attacked in the first place, kind of thing. So I think what I'm seeing more pragmatic customers look at now is really look at it from an inside-out perspective and say, okay, hey, here's all of the stuff that I'm trying to defend, and do I have the controls in place to protect against all of these different areas? And the MITRE attack framework is certainly one that comes up quite a bit for us.
Interesting.
Yeah, I agree on that. When our clients see that we project the attacks and the threats into the MITRE, they're reassured to see what we do cover. Absolutely, that is one point. But I'd say that nothing beats after 1 month, is somebody still looking at your alerts? Is somebody still, taking time to look at that? Have they got too much fatigue and they just whitelisted everything? Or is your AI still being used in a good way? So very frequently we'll have an independent pen tester come in and try it out in one of our partners, one of our customers' infrastructures. And what we notice is that it's important to have good detection levels. It's good to be sensitive. But if you have to spend 2 hours on it per day, and people do spend 2 to 3 hours on some NDR solutions, it's just not worth it. That people will get fatigued and they won't look. So for us, the KPI is, are people still looking at your dashboard?
That's great.
Excellent. So there's more questions coming in. Let me just move this over here. And the next question, I was wondering exactly what kind of customers are using INEA's threat detection SDK. Is it vendors or in-house teams, and standard IT environments or other sorts of networks? Danny, do you want to tackle this one?
Yeah, sure. Well, I would answer a bit differently. I would say anyone who needs to provide threat detection capabilities as an actionable software component in a tightly integrated and performant way would require, at least they have to take a look at the threat detection SDK we are providing, which is unique in its genre. This is because actually from everything which is being identified in the network and then providing additional security insights on top in a very performant fashion is something many people are looking for. And the perfect example for that is the new shift in security called the SASE paradigm, where security is now seen as actionable components. So I would say that our customers would be from small to mid-sized companies, which could be firewall vendors, NDR, XDR vendors. They can be in-house teams building solutions to secure their clouds, for example, like to have east-west firewalls into their clouds. And recently, what we are seeing is that we are seeing people even in the Soho gateway or wireless access points. These small CPE platforms, which now has more and more processing capabilities and all that, are able to handle security as well. So there is DPI and threat detection capabilities being asked for these kind of solutions.
Interesting.
Thank you, Danny. All right, the next question is about zero trust. And the question is, how does NDR fit with zero trust? Rudolf, do you want to tackle that one?
Sure. Yeah, I was wondering, you can't get through a security webinar these days without the zero trust term coming up, right?
There it is.
So I think, look, what I always tell customers is like, there's no one thing for zero trust, right? I mean, zero trust is a process, it's people, it's technology, etc. I think specifically to answer the question though, NDR, I think has a role to play. If you're familiar with the kind of the NIST framework around zero trust, they talk about continuous diagnostics and mitigation. And I think that's really the role NDR has to play, is give you that continuous diagnostics, because part of zero trust is continuously having visibility on what's happening in your infrastructure. And as we talked about, the network and NDR plays a big role there. I think our perspective, as I said kind of in the intro, is can we build this, as much through all of the other network capabilities, right? So network access control, for instance, or segmentation, micro-segmentation, things of that nature. So that's really how we think about zero trust and NDR specifically in the context of zero trust.
Thank you. It looks like we have time for one more question. And William, let me ask you this one. How do your guests handle drift once a customer deploys their product?
All right, so yeah, so drift meaning models that are, over time will change and may not be as efficient over time. Models will drift. So we let our models evolve for our clients. They learn what is normal and what isn't. And this is really just good data science. This is not new. Model drift is something that's been known for a very long time. And we're the ones who monitor drift. So every week when our models are retrained, we have very advanced statistics on what they're doing. So we have a lot of explainability. We know what characteristics are drifting. We know if that drift is normal, and is that linked to something that could be malicious? Is somebody trying to poison the data? So we have metrics for that. And if we find that there is too much drift and that one of the characteristics could be troubling, we will alert the client. We will say, we haven't found a threat, but we're finding model drift. And this could be due to adding a lot of new appliances, to misconfigurations, of course, of the tool. That can happen as well. But that's up to us to monitor. And that's down to basic good explainability and interpretability of our models.
If I can add also one more thing to that, right? I think this might also be related to the anomaly detection question from a few slides ago, because I think there's so much, frankly, FUD around AI, right? And that sometimes things like anomaly detection can look like everything is a threat in the environment, right? And so in cases like that, like drift is actually a good thing, right? Where the networks do change. And like I think William did a great job of enunciating how I think good data science can deal with it, right? So I don't think it's something you necessarily have to shy away from. You just have to be prepared for it.
Yep.
Excellent. Thank you, William. Thank you, Rudolf. And Laura, back to you.
Thank you very much. Well, thank you very much. Well, Holger and our guest, and I have certainly learned a lot, and I feel a lot more reassured that you guys are out there on the job. And you mentioned, I want to say for our audience, thank you for attending. And Rudolph mentioned the KPI results, and just a reminder to you that as our thank you for attending this webinar, you will receive in your inbox a copy of the complete survey results, even though we could only handle a few highlights within this discussion time period. So once again, thanks to all of you for attending. Thanks to our marvelous guest. And Holger, always a pleasure. Thank you for hosting us.
Same here. Thank you, Laura.
Thank you, Laura.
Thanks.
Thank you.
Thanks.
Bye-bye.